Dear students, welcome back. In the previous session, we have seen the dynamic stabilization of the glenohumeral joint. Now, today in this session, we are going to see the cause of dynamic stability. So, the requirements for dynamic stability of the glenohumeral joint is vary somewhat throughout the same range. So it is varying in different degrees of motion. Okay, now we will see what is going to happen here. The anterior stability is considered to be the function of subscapularis muscle, while the infraspinatus and the teres minor muscles protect the humeral head posteriorly. Anteriorly, the humeral head is supported by the subscapularis, whereas the posterior aspect, the infraspinatus and teres minor muscles protect the humeral head. Okay, next, and some common stability requirements exist regardless of the plane in which the humerus is moved. That means in the case of flexion, the plane is going to change. In the case of abduction, it is moving in another plane, whereas in rotation movements, the plane is different. Though the plane is different in the movement of humerus, but for all the planes, there is a common stability requirements are present. Okay, so in any plane, if the humerus is moving, these stability requirements are common, and these requirements are present during the movement of humerus in any plane. Okay, now we will see those common requirements. Equilibrium at any point in the range of function. Equilibrium at any range of function of the force of the prime movers. First one is the force of prime movers, and second one is the force of gravity, and the third one is the force of compressors and the steerers. So these are the main three common stability requirements at any point in the range of function or motion. What are they? So one is the force of prime mover, and next one is the force of gravity, and the next one is the force of compressors and the force of steerers. So these are all the common stability requirements. Some investigators like Inman, Saunders and Abbott approximately add a fourth point here. So the fourth point is the force of friction and the joint reaction force. That means any shear force within the glenohumeral joint, creates some friction across its joint surfaces. That means the head of the humerus as well as the glenoid fossa. If there is any gliding force is existing between these two, that is the shear force which caused by shear force. That means because of these two contact surfaces, it creates some friction across the joint surfaces. Okay, more importantly, all compressive forces that snug the head into the glenoid fossa must be opposed by. So the forces which snug the head into the glenoid fossa must be opposed by an equal force from the glenoid fossa in opposite direction. That force is called as joint reaction force. So here the arrow marks which are mentioned in this pic is the joint reaction force. These are all the joint reaction forces. Okay. So when all equilibrium factors are intact, that means when all equilibrium factors are intact. What are the equilibrium factors? One is the force of prime movers, and the force of gravity, the force of compressors and the steerers, and the force of friction and the joint reaction force. So when all these equilibrium factors are intact and operating normally, and they are working normally, then what happens? The head of the humerus, this is the head of the humerus, rotates on a relatively fixed center of rotation. So it is relatively, the head of the humerus rotates on a relatively fixed center of rotation with only a significant excursion of the axis occurring in the early range of elevation. That means, so in the case of arthrokinematics of the glenohumeral joint surfaces, during elevation, what is happening? There is some movement of humerus superiorly. There is a superior gliding of the humerus taking place. See here, there is a superior gliding of humerus is taking place. So this is the only point where this center of axis of rotation is going to change. Then afterwards, this is as the abduction is initiated, such kind of thing is happening. Next, the joint reaction force shifts to the superior fossa but begins to center. So, and once it reached here and begins to return to the central position. Here you can see this is the superior position, and here it is again returning to the central position in this 45 degrees. So again it comes into central position of the fossa immediately, almost immediately. It will not be present at this point only. It will not present at this point only. It is going to return to the center of the fossa, and this is maintained here. If you can see at the 45 degrees it is present here, in the 60 degrees and the 90 degrees also the center of axis of rotation is maintained. There is no change afterwards. Therefore what is happening? So only at the initial stages only there is a change of center of rotation afterwards, and it is maintained normal throughout the range of elevation. Okay, this is the thing normally happening during the elevation. So when all these equilibrium factors are intact and operating normally, this is the thing happening here. So what is happening here? So the head of the humerus rotates on a relatively fixed center of rotation with the only significant excursion of the axis occurring in the early range of elevation. Afterwards, it is maintained at one point only during the elevation of the remaining range of elevation. Okay, now, so here another important thing, so we have seen the normal functioning and the dynamic stability, how the dynamic stability is maintained. These are all the stabilizing factors and all. Okay, then what do you mean by this cost of dynamic stability? Here what is happening? So the superior gliding of the humeral head occurs during normal elevation activities. There are some substantial changes that occurs in the pressure within the subacromial bursa as the humerus moves through its range of motion. These pressures are related to both arm position, maybe it may be a dependent arm, or it may be a loaded arm. Okay, in both the cases, with greater pressures in the bursa is seen as the arms are loaded and maintained in an elevated position. So here what is happening here during normal movements also, so because of this superior gliding of the humerus, so what is going to happen, the subacromial space is somewhat reduced and the pressure is increased in the structure on the structures which are present in the subacromial space. So what are the main structures present here is the rotator cuff tendons and the subacromial bursa. But majority at this space, the tendon of supraspinatus is present. Here the supraspinatus tendon is going to compress a lot when compared to the remaining tendons of the rotator cuff. Okay, so by the cause of the supraspinatus tendon and the subacromial bursa, or these two things are taking some pressures and which helps in the dynamic stability. Though all the equilibrium factors are present also, there is some pressures are taken up by these structures. So these are the first structures which are going to be affected. These are the four structures are going to be affected with increasing age, and these are the structures which undergo degeneration also. Okay, so when these pressures are going to increase, so mainly in the loaded arm the pressure is going to increase more than when the arm position is in normal. Okay, so what are the degenerative changes are going to taking place here? So during this degeneration occurs, there is a high incidence of shoulder pain. There is an high incidence of shoulder pain that occurs with increasing age. And also the pain may also occurs due to the narrowed acromioclavicular joint. So in both the cases the pain is occurred at the shoulder region, but the pain which is occurring in these two conditions are going to be varied. So in one condition, in some range of elevation only the pain is present. In another condition, in that previous range of motion they don't have pain. Beyond that range it is having some pain. That thing we are going to see now. Okay, the complaints, whether the complaints of pain are due to the tendon trauma, that means the supraspinatus tendon, or maybe a narrowed joint spaces, that is the acromioclavicular joint spaces. Okay, there is a symptomatic and asymptomatic rotator cuff tears are seen in almost all people over the age of 70. In that also with the supraspinatus, are likely to show lesions before the other tendons of the cuff. That means, so out of these 4 rotator cuff tendons, so that is the sits, isn't it? In this, the first rotator cuff muscle is going to be teared, means the supraspinatus only. If anybody is complaining with any other rotator cuff tendon tears, definitely the supraspinatus is also affected. So you have to go through this rotator cuff tendon lesions. First see the supraspinatus tendon, whether it is intact or it is injured. Then only you have to check for the remaining 3 rotator cuff muscles. Okay, so that is the thing. Now, and how the frequency of the supraspinatus lesions occur. The frequency of the supraspinatus lesions is comparatively high with the other rotator cuff tendon tears. It is due to, so the supraspinatus tendon injury is due to the limited vascularity, that means limited blood supply, and also its role both in the moving arm. So these are all the moving arm, both in the moving arm as well as the dependent arm, In both the cases, during static as well as dynamic, this supraspinatus muscle is going to be affected. This muscle is going to work in both the cases. In static stabilization also, the structures of rotator interval capsule, if it is not enough to hold this dependent arm, then the supraspinatus tendon is going to hold this dependent arm. Okay, so at that stage also the supraspinatus is going to work. Because of all these reasons, so the supraspinatus muscle injury frequency is more. Okay, and also, unlike the other glenohumeral muscles which contract during their primary activity and then relax, so that means the remaining glenohumeral muscles are going to contract during their primary activity and then they will relax. But in the case of supraspinatus, it is contracting, not only contracting in their functions, that is in flexion, abduction and the loaded dependent arm, and also but also it is passively tensed, that is passively tensed in unloaded dependent arm in almost all positions of the glenohumeral joint. So that means the supraspinatus muscle plays a key role in maintaining the glenohumeral joint static stability as well as the dynamic stability. In the case of dynamic stability, at the cost of supraspinatus functions, supraspinatus structure compression, the dynamic stability is occurring. Okay, so now this is the thing happened in the case of cost of dynamic stability. So I have told that at what range the pain is occurred. In the case of rotator cuff lesions, typically pain is produced with the shoulder motions between 60 to 120 degrees range of motion. 60 to 120 degrees of range of motion, there is a pain which is combined glenohumeral and scapular abduction. So this range is called as painful arc. This range is called as painful arc. What is the range for painful arc? From 60 to 120 degrees of combined glenohumeral and scapular abduction. This range constitutes the painful arc. So if the pain due to acromioclavicular degeneration, so then it is also mentioning some shoulder pain. It is also showing some shoulder pain. What is the range of this pain here? So the pain is typically found when the arm is raised beyond the painful arc. That means beyond 120 degrees of abduction, the pain is occurred due to acromioclavicular degeneration. Okay, this is happening in the cause of in the case of this supraspinatus rotator cuff tears as well as the acromioclavicular degeneration. This is the difference. So pain occurs when the arm is raised above the painful arc, means that is acromioclavicular degeneration. If the pain occurs within the 60 to 120 degrees range of motion, means then definitely it is a rotator cuff lesions. Got it? Yes. Next, any disruption of the synergetic action of the four equilibrium factors, what I have mentioned earlier, for dynamic glenohumeral joint stability may lead to varying centers of rotation of the humeral head and causes excessive excursion of the humeral head on the glenoid fossa. That means what happened? So the factors which are helping to maintain the equilibrium are affected. That is called synergistic action. So what are the structures? ఏ స్ట్రక్చర్స్ అయితే ఈక్విలిబ్రియంని మెయింటైన్ చేయడానికి ఉపయోగపడతాయో, సో ఇఫ్ దోస్ స్ట్రక్చర్స్ ఆర్ ఎఫెక్టెడ్, then what is happening here? The dynamic stability of the glenohumeral joint will be affected. That means it leads to various centers of axis of rotation. Normally at initial ranges only there is some change in the axis of center of rotation, but in the remaining range of motions it is maintained normal. So in this case what will happen? The center of rotations are going to change if the equilibrium factors are not maintained. So then what will happen? In such conditions, there is a mechanical deviations of these structures causes degenerative changes of the joint besides the rotator cuff. So if the equilibrium factors are not maintained and it causes excessive excursion of the head of the humerus on the glenoid fossa, leads to changes in the center of axis of rotation, which causes mechanical deviation of the humeral head, leads to degenerative changes which are present beside the rotator cuff muscles, which leads to subluxation of the joint. That means if dynamic stability is not maintained, the joint may going to subluxate, or it may going to dislocate also. It may finally dislocate also. So what are the variations which causes such a kind of dislocation? What are the variations which cause such kind of dislocations? That means there is an improper anterior tilt of the glenoid fossa occurs, and excessive retrotorsion of the humeral head, and weakened horizontal steroids. Weakened horizontal steroids leads to dislocation of the glenohumeral joint. Okay, and these are all about the cause of dynamic stability. So if the equilibrium factors are not maintained, what will happen? Subluxation and dislocation may occur. So if it should not be occur means it has to be maintained in equilibrium. That means the stability requirements, the force of prime movers, force of gravity, and the force of compressors and steerers, and the force of friction and joint reaction force should be apt, and they have to act, all these factors are intact and operating normally. Then only the head of the humerus will be rotating in a relatively fixed center of rotation. Okay, so at the cost of compressing of the supraspinatus tendon and the subacromial bursa in the subacromial space. So this is called cause of dynamic stability. In the next session, we are going to see the integrated function of the shoulder complex. Okay. Thank you.